So second last thing about trigonometry is you'll see questions like this in the exam. Solve the equation 5 tan square y minus 7 is equals to 11 tan y. I'm going to rearrange this and I get 5 tan square y minus 11 tan y minus 7 is equals to 0. I hope you can tell that this is a hidden quadratic equation. Let tan y equals x. So then you get 5x squared minus 11x minus 7 is equals to 0. I'm going to take help of the calculator very smartly to get the answer. I can't, it's a decimal value. So that won't work. I will have to apply the quadratic formula, which is x equals minus b plus minus square root b square minus 4ac upon 2a. X equals 11 plus minus square root 11 square minus 4 times 5 times minus 7 is 261 upon 10. So we get x equals 2.72 and x equals minus 0.516. Okay. Now replace x with tan y again. I forgot to mention the domain at the start of the question. Tan y equals minus 0.516. The domain here is where or when y is between 0 to 360 degrees. Okay. So now we know how to solve this. We have to find alpha first and then plot it in the corresponding quadrant. So tan inverse, and we're in degrees because the domain is between 360 degree and 0 degree. So set your calculator at degree. Tan inverse 2.72 is 69.8 degrees. And for the other one, I'm finding alpha at tan inverse plus 0.516. For absolute angle, you must take tan inverse of positive value. So tan inverse 0.516 is 27.3. So now let's plot these. Tan is positive in the first quadrant, it adds sugar 2, and in the third quadrant. So 69.8 and 69.8. So one of the answers would be this, and the other answer would be this. So the two values of y are 69.8 and 180 plus 69.8. Which is 249.8. And for the other one, tan is negative, since this was negative in the second quadrant, fourth quadrant. So this is 27.3 and 27.3. So we are going to find this angle, which is 180 minus 27.3, and this angle, which is 360 minus 27.3. So we get 180 minus 27.3 is 152.7. And 332.7. All right. Moving on to another question like this. Do you guys have any questions so far? It was a hidden quadratic equation, and then it was trigonometry that we learned in the first lesson of this chapter. Okay. One more quadratic equation, hidden quadratic equation, and then we move on to trigonometric identities. Okay. So it is solve 10 sine square x minus 5 cos square x plus 2 equals 4 sine x. Domain is the same between 360 and 0. Okay. Now the problem with this equation is it has cos term as well as sine terms. It should either have sine term or cos term, so that we can say let sine x is equals to y or let cos x is equals to y and get a quadratic equation. How do we get there? By using this identity. Sine square x plus cos square x is always equals to 1. So what I'll do, I'll replace this with 1 minus sine square x. So we get 10 sine square x minus 5. Instead of cos square x, I'm writing 1 minus sine square x plus 2 equals 4 sine x. So we have 10 sine square x minus 5 plus 5 sine square x plus 2 minus 4 sine x equals 0. So we have 15 sine square x minus 4 sine x minus 3 equals 0. Sine square x minus 4 sine x minus 3 is equals to 0. Yes, so far so good. Now we have a typical hidden quadratic equation. Let sine x equals, let's call it u. So we have 15 u square minus 15 u minus 3 is equals to 0. Now that trick is going to work. Directly solve this from your calculator. You'll get u equals minus 1 over 3 and u equals 3 by 5. Take this one step backwards. You will need two brackets. If 8 into 0, 3 goes to the other side becomes 3u. Minus 1 goes to the other side becomes plus. 5 goes to the other side becomes 5u. 3 goes to the other side becomes minus 3 equals to 0. Now replace u with sine x. Now we know what to do. Find alpha first, then plot them in their respective quadrants and get the values of x. So alpha here will be sine inverse 1 by 3 because alpha is absolute and absolute means positive. And here alpha is sine inverse 3 by 5.
Negative 19.47.
Okay, thank you. 19.47. It's okay if you stick to one decimal place right here as well. Because your final answer should also be in one decimal place. So yahin pe 1 dp pe kar lo, so it's fine. Okay, now this would be with sine.
36.9. Oh, sorry.
दूसरा वाला बता रहे हो? Okay, that is 36.9. All right. So now let's plot this. Sine is negative at the in the first part. So sine is negative where here and here. Add sugar, 2 and coffee milk. So this would be 19.5 and that would be 19.5. Since our domain is from 0 to 360, so this would be one of the answer and this would be the second answer. One of the answers is 180 plus 19.5, and the other answer would be 360 minus 19.5. 180 plus 19.5 and 360 minus 19.5. Which is 199.5 and 340.5. For the other set of answer, our sine ratio was a positive value, so that means that angle gets plotted in the first quadrant, in the second quadrant. One of the answers is the same, the other answer is this. So we have, what was our variable x? These are also x. So x is 36.9 and 180 minus 36.9. 143.1. Yes. So these are the four answers to the equation given for solution. All right. That's all from hidden quadratic equations in trigonometry. We'll see more of these questions when we start the worksheet. Now let's conclude this topic by talking about identities. So the AS identities are pretty precise identities. You need to know two identities. One of them is cos square x plus sine square x equals 1. I should have written sine first because that's the convention, though it doesn't really matter. And the other one is that you must know that tan x equals sine x upon cos x. All right. Now let's use these to prove a few identities. First one, oops, I missed something. Chalo, wind में कराते हैं, I hope I remember. Okay. Let's prove an identity which is 2, 1 minus 2 sine square x is identical to 2 cos square x minus 1. Now you can either prove that the left hand side can be written as the right hand side or the other way around. So I'll start from here. I have to somehow use identities and get this in this form. So now we can see that the given side that I'm starting with has sine square x and the other side has cos square x. So I know how to change this into cos square x. I'll use 1 minus 2 brackets, and instead of sine square x, I'm writing 1 minus cos square x. So that gives us 1 minus 2 plus 2 cos square x. So that's 2 cos square x minus 1. Next is one minus cos squared x upon 1 plus sine x is identical to sine x. You have to show that when you use identities at the left-hand side, on the left-hand side, you get the right-hand side. Right-hand side is just sine x. At the left-hand side, I have 1 minus cos square x upon the denominator. So first thing we should do is change the left-hand side into a single fraction. So I'm going to take LCM here. 1 plus sine x. And then we have 1 plus sine x minus cos square x. So now the right hand side has only sine x. So what we can do is change this into sine square x. Let's do that. We have 1 plus sine x, then a minus sign, and we get 1 minus sine square x, the identity. And then in the denominator, we have 1 plus sine x. Okay. Simplify the numerator and we're only left with sine x plus sine square x. And I'm going to take sine x common in the numerator. One plus sine x in the bracket. And the denominator is also 1 plus sine x. So this and this cancels and we get sine x. Any questions?
No, miss.
Oh. Another identity, which is 1 minus tan square x upon 1 plus tan square x is identical to cos square x minus sine square x. Okay. Left hand side has tan. Right hand side has both cos and tan. So we have to use the second identity, which is break tan into or change tan into sine x over cos x. So we have 1 minus sine. So if there's a square on tan, we also have to write square here and square here upon 1 plus sine square x upon cos square x. So we have cos square x here, cos square x minus sine square x. And here we have cos square x, cos square x plus sine square. So I've only taken LCM. So now I can see that the denominators of both the fraction are the same. So we cancel this and we cancel this and we get 1 and 1 here. And if we divide with 1, you just get 1. So you can ignore that those ones in the denominator and we get cos square x minus sine square x. And this we know is also 1. Cos square x plus sine square x. We get a 1. So we got the required identity. And the last identity we want to practice is 3 minus 6 cos square x upon sin x minus cos. And you have to show that this would be identical to 3 bracket sin x plus cos x. Let's start from the left hand side. Take 3 common. Let's take 3 common. So 3 common in the numerator, and we get 1 minus 2. And simultaneously, let me just change this. We need to change this into sin square x minus 1. And let's see how that goes. So I'm going to change cos square into sin square x minus 1 upon sin x minus cos x. तो क्या होगा वैसे? Don't think we're going anywhere. Stop writing अभी, इसको कॉपी नहीं करना. अगर आता है तो कॉपी कर लेना आंसर. Okay, so we get 1 and plus 2, so that's 3. 1 plus 2 is 3 minus 2 sin square x. But I need a cos and a sin both. Not just sin, that's not really helping. किसी तरह ना denominator cancel कर.
Why is it 3 minus 2 sine square x? 1 नहीं है?
1 minus 1 minus 2 minus 1 1 plus 2 हो जाएगा ना, इसलिए 3 लिखा. Won't it be 3 outside and we have 1 minus 2 sin square x and then plus 2. So 3 out.
ठीक है.
So no, this is not taking us anywhere. I need both sine and cos. How do I get both sine and cos? Let's see. So clear this. 3 to common ले लेते हैं. And we get 1 minus 2 cos square x. Let's just stay here. And then we have sin x minus cos x. Achha. Now I need both sine and cos. So I think what I'll do is 1 को change कर लेते हैं. I know 1 is equals to sin square x plus cos square x. So that way also I'm getting both sine and cos term in the numerators. Next I'll figure out how to cancel the denominator with that. So 3.
Sorry, I have a question.
हाँ जी.
जैसा आपने -6 cos square x को 1 minus 2 cos square x कैसे बनाया?
3 कॉमन ले लिया ना उसका.
ओके, तो मिस्टर उसका 3. ओके, ऑलराइट. तो 3 माइनस भी तो होगा सर. इट विल बी 3 minus 3 ब्रैकेट.
जैसे 3 minus 6x होता है, तो उसको हम क्या करते हैं? 3 कॉमन ले लेते हैं. 3 की जगह आ जाता है 1 minus 2x.
अच्छा, आपने टोटल. ओके, ऑलराइट.
ठीक है, फैक्टराइज किया. ओके, सो अब 1 की जगह में लिख के देख रही हूँ sin square x plus cos square x. Yes, now we're going somewhere. And then minus 2 cos square x sin x minus cos x. Okay, this gives 3, and then I have sin square x minus cos square x. And in the denominator, I have sin x minus cos x. And now I'm going to use the algebraic identity. A square minus b square is a plus b. times a minus b. This cancels this and we're left with 3 sin x plus cos x. That is what we were supposed to show again. So we have 3 times sin x plus cos. एक और काम भी हो सकता था इसका. Can I clear the screen?
No, miss,
Yeah.
just a minute.
I think we can also try going from the left hand side to the right hand side. That is how you can prove identities as well. अगर मैं left को right पे बनाने की कोशिश करूँ, so let me start. There's a 3 here, and then there's sin x plus cos x. At the right hand side, the denominator is sin x minus cos x. So what I'll do, I'll multiply this with sin x minus cos x, multiply and divide as well. Because I know कि मुझे यहाँ पे denominator में यही चाहिए. So I'm going to start from here. Okay. Now I'm going to, I have the denominator. Denominator is set. Okay. And for the numerator, I'm using the identity that a plus b times a minus b equals a square minus b square. So I have 3 times sin square x minus cos square x. Okay. Ab numerator mein all that's left to do is the numerator is a cos only term. So we can also get a cos only term by changing this into 1 minus cos square x. Let's do that. 3 bracket 1 minus cos square x minus cos square x upon sin x cos x, and then this becomes 3 1 minus 2 cos square x sin x minus cos x upon sin x minus cos x, and now we have what we needed, 3 minus 6 cos square x over sin x minus cos. So sometimes it's simpler to go from right to left, and sometimes it's simpler to go from left to right. Here I think it was, for me, it was simpler to go from right to left. I'm going to send you the worksheet and let's take a look at it. Question number 1 of the worksheet. So that sin x tan x may be written in this form. So this is a question on identity. So that this can be written like this. Okay. So I'm going to change tan x into sin x over cos x. So we have sin x times sin x upon cos x which
And
becomes,
then use that identity for sine x squared.
yes, sine square x over cos x, and use the identity 1 minus
1
cos
minus cos square x.
x. Part. Hence solve the equation 2 tan x sine 2 sin x tan x equals to 3. Hence, polars, we have to use the previous result, which is this gets replaced with this. So let's do that. 2 stays. And then instead of sin x tan x, we have to use the previous result, which is 1 minus cos square x upon cos x equals 3. And the
Speech
domain,
1 minus cos x, but plus.
sorry?
Nothing else. I thought we could divide the cos x.
Okay. Acha, now we cross multiply, get a hidden quadratic equation. So we have 2 minus 2 cos square x equals 3 cos x. A little bit of rearranging is needed. So we have 2 cos square x plus 3 cos x minus 2. So let cos x equals u. So I have 0 equals 2u squared plus 3u minus 2. So I'm getting u equals half from my calculator, and I'm getting u equals minus 2, which I will use to give me the two factors 2u minus 1 and u plus 2 equals to 4. Now we replace u with cos x. Find the respective alphas. Cos inverse of alpha equals cos inverse 2. So are we in degrees? Yes, we're in degrees because the question says so. The domain is in degrees. Cos inverse of is 60. Cos inverse 2 is not possible. Cos का तो हमें ग्राफ पता है, 2 तक तो जाता ही नहीं है. Cos का ग्राफ कहाँ से कहाँ तक जाता है? 1 and minus 1. So there's no value of x that will make cos x 2. So cos x जाता ही नहीं है 2 तक. So this will be no solution. The calculator will say math error, and you will not write math error. You will write no solution. Okay. Now, cos is positive in the first quadrant. Add sugar to coffee in the last quadrant. So 60 here, 60 here. Since our domain is from 0 to 360, we always only look at the positive angles. So these two. One answer would be 60. X equals 60. And the other one is 360 minus 60, which is 300. So that's all for today. I'm going to leave you guys with a few homework questions. And see you guys tomorrow, inshallah. Allah Hafiz.
All right.
Yeah.
Allah Hafiz.